Section 1.8a is about interpreting graphs. We're going to teach you to look at graphs and interpret them to know what they're saying, how to examine the relationship. These are typically graphs that you might see in books or in magazines or on TV or whatnot. We'll start with the definition of what a function is. A function is a relationship between two values. We call them an input and an output. Typically when you plug something into a function, you'll get a value out. A simple example would be like y equals x plus 2. If I were to put a 1 in for x, that's called the input. 1 plus 2 is 3, then the y would be 3. And we'd create an ordered pair of 1, 3. If I were to put something else in, like a 5 in for x, 5 plus 2 is 7, therefore y would equal 7. That's a specific example of a mathematical function. We're kind of going to use that as a broader term in the next couple of examples. A coordinate system is a place where you're going to graph functions. It's the intersection of two number lines called the horizontal axis and the vertical axis. Now I'm going to take this small graph here and I'm going to teach you what certain parts of it are called. First we're going to start by labeling the axes. The horizontal axis is this one. That's the horizontal axis. I remember that because it looks like the horizon. If you look out along the horizon, maybe a sunset, I remember that because of the word horizontal. This is also known as the x-axis. It's called the x number line or the x-axis. That's where we're going to label x values. The one down here, the black line that goes up and down, that's called the vertical axis. And I remember that. There used to be an old Mountain Dew commercial that said, "Get vertical with dew," which means up and down. So that's how I remember it's the vertical axis. This is also known as the y-axis. We typically graph y values along that axis. Now where those two axes meet is right here at this point. This has a special name. It's called the origin. And the origin is labeled using these two numbers 0, 0. Now what that means is the x value at that point is 0 and the y value at that point is a 0 also. Now as we travel to the right, we increase the x value. So if I go this way, I get 1, 2, 3, 4. So this little line represents the x of a 4, and then as I go up, 1, 2, 3, I could put a dot here. This spot is given the name 4, 3. Now that's called an ordered pair. Pair because there's two values there, and it's ordered because we always put the x value first. So the x value goes first and the y value goes second. So the x-axis is the first number and the y-axis is the second number. And that's called an ordered pair. And you could list ordered pairs all over the place. We could do 1, how about this one? 1, 2, 3, 4, that's 1, 6. We could do 7, 7, 7. But you get the idea. Anything that moves to the right is an x value, and anything moves up is a y value on this coordinate system. And we're going to learn to look at coordinate system graphs and interpret information from them. We have a couple more definitions to get through, and one of them is called the independent variable. The independent variable is the input that we talked about earlier, and we said it's an input for a function. It's also the value that does not depend on anything else. When you graph an independent variable, typically you put that on the x-axis, and usually it's something like time, or, well, time is usually a very good independent value, but it's a value that doesn't depend on something. And as you see in some of the examples we're about to do, you want to be on the lookout for the value that is independent. It's on the x-axis or the horizontal axis. That's where we put the independent variable. Also, there's a dependent variable, which is the output, or it's a value that depends on something else. It depends on the independent value, and we're going to graph that on the y-axis or on the vertical axis. So again, be on the lookout for independent and dependent variables in the next couple of examples. Here we have some examples of interpreting graphs. Our first one here says that we're to name the ordered pair at point E and explain what it represents. So take a look at this graph. Notice the horizontal axis, or the x-axis as we called it, also known as the independent value, represents the days. And then the vertical axis, or the y-axis, also known as the dependent value, is the percent of blood flow. So if you find an ordered pair right there, we can see what that point might represent. It's 6 units to the right on the x-axis and 100 units up on the y-axis, so it creates an ordered pair 6, 100. Now that means that after 6 days, there's 100% normal blood flow following a concussion. So we can interpret some information based on our knowledge of how to read this graph. Now we want to name the ordered pair at point D. This one's not quite so perfect. It would be sort of a guess here, but it looks like it's to the right 4 units and up, I don't know, 97 units. Yeah. So that represents 97% blood flow after 4 days of the injury. So you kind of get an idea that we can read the independent value down below and then find where it corresponds to the dependent value on the side and get a picture painted of what this graph is telling us. Here's another example. It says in warm climates, the average amount of electricity used in homes each month rises as the daily average temperature increases and falls as the daily average temperature decreases. Identify the independent and dependent variables for this function. Well, there's two things that we're comparing. We're comparing electricity to temperature. So the question we have to ask ourselves, does the electricity that you use affect the temperature outside, or does the temperature outside affect the electricity that you use? Well, the answer obviously is that the temperature outside affects the electricity, so we call the temperature the independent variable. Temperature just happens, there's nothing you can do about it, but the amount of electricity that you use is dependent on the temperature. So temperature is independent and the electricity is dependent. So if I were to graph this, I'd put the temperature on the bottom and the electricity on the side. Here's another example. In a particular club, as membership dues increase, the number of new members decrease. Again, identify the independent and the dependent. So does the membership depend on the dues, or does the dues they pay depend on the membership? Well, the membership dues is the independent variable. What they charge is what they charge, and then people will come in if they want to pay it or not. So that's dependent. Here's another example of looking at a graph and interpreting it. It says this graph represents the temperature in Miss Ling's classroom on a winter day. Describe what's happening in the graph. So we have time down here as the independent value, so time just marches on, and then the temperature somehow goes up and down. So what you have to do is just describe a situation where this could be affected. Well, maybe the temperature starts out low, and then she turns the heat on, and then throughout the day the temperature dips, and then the heat kicks on, and it goes up and down, up and down. Then at the end of the day when she goes home and turns it off, the temperature goes back down. So it's a graphical representation of a situation that happens, and you're going to be asked to write those. Here's another example. If you want to pause the video and give it a try, you could do that. This represents Macy's speed as she swims laps in a pool. So time versus speed, that's the function. Time is the independent value. Speed is the dependent value. Time is the input. Speed is the output. So what's happening? Well, she starts with 0 speed, and then she picks up speed. As she starts approaching the wall, she slows down, and when she touches the wall for a moment, she isn't moving. And then she picks speed back up, and it constantly keeps going as she swims laps.